So you are all warmly welcome to the 10th. Notice we have an anniversary, 10th INGENIUM Staff Academy webinar already. So my name is Tiina Lukkainen, and in addition to my lecturer's job here at XAMK, I also work for the INGENIUM Staff Academy. And the main objective of our staff academy is to bring teachers and researchers together to share their best practices. Of course, we have the live staff academy during the 10 days, but we get so many good proposals from our colleagues that we wanted to organize this series of webinars to showcase as many as we can. And today we have a very exciting topic. We're talking about gaming. And we have 3 specialists giving talks today. So our first speaker is Associate Professor Markus Nohlberg from Sweden. And he specialized in the human aspects of cybersecurity. And today he will talk about a pedagogical cybersecurity card game, Siguru. And secondly, Professor and Vice President for Teaching Rainer Neumann from Germany will talk about how gamification can act as a driver for motivation. And our third speaker comes from our Romanian partner university. Professor Cristina Vatavu will discuss game-like activities in electrical circuits. And the presentations will take about 20 minutes. And after that, we will have 10 minutes for questions and discussion. And of course, you can also comment in the chat all the time, also during the presentation. And now, first, I would like to give the floor to Markus.
Thank you. Then we'll do the exciting aspect of sharing here. So we'll see if do that well. I hope you see my presentation. So that aspect worked. Thank you. Now I will just move so I see some faces here. So thank you all for having me and having this event. I'm happy to take any questions. And if you actually want to ask questions during the presentation, that's also going to be fine. I tend to talk a little bit quickly when I get excited, and this is something I get excited about. So please let me know if I'm speaking too quickly or if it's difficult to hear what I'm saying. So I'll talk today about my experiences from developing a pedagogical game, which is called Siguru. And some background about me before I begin. I've been in IT for well over 30 years now. I've been into research for 25-ish years. And I typically have researched the human element of security. And when I started this some 20 years ago, it really wasn't a popular topic at all. We didn't speak about humans. We assumed that we could stop all issues related to humans by implementing new technology and just building away the human element. This has apparently not been as easy as we had thought. So one of the things I'd like you guys to imagine now is what's a good password. Just think a little bit about what a good password is for you. So I'll sip a cup of coffee and just imagine what's a good password. I'm guessing that many of you imagine that as something like this. You think this seems like a really good password to have somewhere, and it's probably really secure. And in one way it is that it's going to be difficult to brute force it. But if we go back, can any one of you remember this password? Could you reuse it? Does anyone remember more than the first 2 characters? So that's a difficult aspect to have, because as we see, this is one of the issues where human stands for what we usually talk about, the 95% of successful attacks has primarily exploited aspects of human weaknesses. That doesn't mean that they only exploit human weaknesses. Attackers are really happy to also try to use technological means, but the first way to get a hold in the organization is typically almost always by exploiting human weaknesses, like our inability to pick a good password. And by the way, the password I just showed you isn't a good password. It's what a very technical person would say is a good password. A good password is actually a passphrase, which is 4 words, and then you're set. So that is a security misconception. But what we did see is that as this went on, we saw more and more issues of humans actually doing things they shouldn't do, but really not having any tools to address it. So we don't have a way to build away the humans, so we have to make humans better at handling security. And this has been done in many ways. And yeah, 5% of the research funding typically goes to the human element. So 95% of research funding typically go to technical aspects, 5% to human aspects, which is a bit of a challenge. So of course, there's a lot of existing solutions or proposed solutions on how to address this. And most of you are working, I guess, so you have most likely been exposed to this. So you have had security lectures where someone like me has a lecture telling you that security is important. Never click on links. You might have heard that a couple of times, which is difficult if you want to use a seminar like this. So you shouldn't click on links, you shouldn't give personal information online, but that's difficult to do in a professional setting. You probably have tried e-learning. In many cases, you use nano-learning, which is short email lectures of a minute or two, which you probably suffer through. There might be campaigns with posters, etc. And one of the trendy topics that we talk a lot about is gamification. So gamification is something that a lot of people want to try because a lot of nerdy people like myself enjoy playing games. The issues with many of the gamification solutions that's available today is that they are A, targeting people who love to play games, which isn't a broad audience on that way, and B, they are typically fairly complicated to get started with. There's a higher learning objective, and that means that you have to spend a lot of time explaining how the game works before it is fun. And indeed, it might be fun, but it takes a lot of time. And they also aren't typically scalable. That is, you have a one-off event or something, but there's not different levels depending on the knowledge base people have. So it becomes either overly complicated or overly simple, depending on the people who are actually playing the games. But most of all, one of the obvious problems is that we still haven't really solved the challenge of the human element. So whether or not the games exist, they haven't worked well enough because we're still clicking links and having poor passwords. So this all goes back to one of my favorite tenets, which some of you might have heard before. And it's the one thing you should remember after today is that it's the humbly named Nohlberg's first law, which is that people hate security, but they want to be secure. That is, no one wants to spend time doing security measures. You just want to be secure. So that is always true, pretty much. So no one wants to do anything complicated. You just don't want to be hacked. And this is something that I see time and time again when I talk to normal people and even security-minded people. So how do you make people suffer through security then, based on the knowledge that people just don't want to spend time with security, they just want to be secure? Well, I realized that doing it in a fun game, where fun is actually the key part, might make this more accessible. And this was actually inspired by a session in INGENIUM in Crete in 2024. We played a game based on art history. And it turned out that we actually had fun. And I know almost nothing about art history, but I really was struck by the fact that we had fun playing this game. And I realized that we could do this in a different manner, but still maintaining the aspect of the game being fun and accessible, because we could start playing the game fairly quickly. So with that as a notion, I had the idea of creating what was then a small game. My notion was to have a couple of cards to beta test. Turns out I'm not good at doing small projects, so this became a bit of a passion project, or depending on if you would ask my wife, an obsession. So I started to develop the game further and further as I saw the potential, and I added more and more features, objectives to the game, etc. So it was rapidly evolved into something fairly substantial and not just a small trinket of a fun game. So the key objectives that was behind the creation of the game was that it was supposed to be very easy to start playing. The target has always been 2 minutes. And 2 minutes doesn't mean that it takes 2 minutes to master the game, but it takes 2 minutes to start playing the games with others. So that's a key point. So of course, it takes a little bit of time to learn how to play the game efficiently, but you can theoretically at least start playing within 2 minutes. It's not a 20-minute thing. Typically, the first round is a little bit awkward, but you get a hang of it very quickly. It should also be accessible for everyone, and that is a massive challenge when you design something. That means that it has to be scalable, it has to be fun, whether or not you're an expert or not, but it should also not be what's called a solved game, one where you can optimize it and always win by not cheating, but by learning the entire game. So those who are very good at security should still get a challenge. So that's an important aspect. It shouldn't be that you can master the game and win all the time. It should be a game that's, well, fun. Also adaptable to individual knowledge, so you can play with someone who's more experienced than you are. It should also be self-sustained. That means that you should be able to play it without having a physical teacher present. We solve this by QR codes and a fairly sophisticated back end, so you can look up terms you don't know. One critical aspect was that we should enable social learning. That means that you should learn from each other while you play. And that's one of the most proven ways of learning a new material. But fun, key point. And anything that was added had to be filtered through the aspect of, was this still fun? We couldn't add anything that made the game less fun and less accessible. So it's a fairly massive design constraint. So in order to reach version 1.0, we did a lot of designs, we did a lot of templates, we used several different designers because I'm really not good at designing stuff. We built a massive web page for all of the terms, which turned out to be exceedingly big. It's like half of a textbook to build. It took a lot of work to do it. And then we actually started to do play tests. But a slightly challenging aspect was that we couldn't really do any meaningful play tests until we had a workable deck and a workable structure, etc. It was a massive success. The beta players didn't want to stop playing the game. I had to stop them playing it after an hour and a half. But we did learn that it was a little bit more challenging to learn the game than I expected. So we created a multi-language based instruction video on how to play the game, which is a 2-minute long video, which took literally forever to get done. And that took a surprising amount of time, and we're still working on improving it. Now, we tested it a lot. We had probably hundreds of players, and the feedback was massively positive. People just really enjoyed the game. So we did get some funding to create a version 2.0 with a good design, a professional design, a redesign of our backend, which turned out to be a fairly complicated project because it involves a lot of web development, but also a kind of a business development aspect of it, because it turns out that it's really expensive to develop something like this. It really adds up quickly when it comes to money. So there has to be an aspect of how you can get this somewhat self-contained at least. And then some final words about what we've done so far. Well, it takes a tremendous amount of time to create something simple. I've been involved in numerous startup projects, research projects, etc., and we always had a different goal than simplicity. Simplicity makes this paradoxically seem like a very simple solution. So often when I talk about this game, people just say, well, it's a bunch of playing cards. That's not really complicated. Or where's the complexity of this? Or why has this been challenging? But creating something complicated for an audience used to complicated things like ourselves in academia, that's actually fairly easy because we adapt quickly to that. This game is accessible for almost everyone, and that meant a completely different experience when it comes to developing this. Another aspect is that fun, the raw aspect of it being fun, beats almost anything else in a game because people will continue to play it. So it might not be the most pedagogically effective game if you look at purely the gameplay, but the fact that people will come back to play it beats out anything else. So a lot of the people designing serious games spend a lot of time on what you want to teach people, which is of course good, but they don't really spend aspects of fun. So I was at an academic presentation when they did a massive survey of all the existing serious games in computer security or cybersecurity. And fun wasn't even an evaluation criteria. So it wasn't a factor when you ranked these games. So out of the 30 biggest one, not a single one was ranked on whether or not people actually enjoyed playing it. And I think that's kind of the key aspect of why games work, is that we enjoy playing them. Another aspect that I've learned is the fact that it takes a tremendous amount of time to gather data if a game works. We worked on that for more than a year with samples. It's somewhat frustrating with the time aspect, but that's the way it is. It takes a lot of time to gather these things. It takes a lot of time to gather data. And also that it's actually really expensive to go from a cheap prototype to a decent production-ready product. It's taken an absorbent amount of time that I never really understood how complicated it was. But also that experience beats IDs. That is that once you get people to actually do this, you get way more useful feedback from having beta players than you do whether or not you talk to experts. So actual people playing the game brings you way more insight than having experts evaluate the game, because it's for the actual users, not for the experts. So rounding up some of the things that's made me very frustrated during the process. Well, design is horribly subjective, but ridiculously important. One of the things we learned early on is that if we do very simple designs and test the game, people will react vastly different to an obvious prototype than an actually ready looking game. So you are way more brutal and you don't spend enough time with it. But once you have something that actually looks like a design, people react differently to it and they just appreciate it more. The game is still the same, but the design and the readiness of it makes a massive difference. And this has taken a tremendous amount of time. It's been a year and a half in progress. I've spent almost a year trying to get the design videos to work well with different audiences, to having testing. I've been gathering data now for a year and 1.5 years since the first prototype, and we're still gathering data. So all of this takes a lot of time. Partly because it's not a lot of people working on this, especially no one full-time, but also just because there's a lot of lead times with everything you want to do. But another aspect is, since testing takes a lot of time, once you are trying something out, you can't really change it. So you have to stick to cycles. And this means that testing takes even longer, because if you're testing something, you have to test it in the entire cycle. So that means that it's difficult to change the game mechanics quickly, which might be frustrating. And since it's a passion project, I've done this almost exclusively on my spare time, which of course is the case for most fun projects, but that also adds up to the fact that it takes way longer than you assumed. I think it took me a couple of months of work to get to the first beta version 2.0, which is massively redesigned, will take almost a year and a half. So that it really takes a lot of time to do these things, surprisingly. But also one of the things I learned is the fact that I had a very clear vision from the beginning, but it's been really difficult to explain that vision before I had the actual game. And that's frustrating and difficult because I had a very strong vision of where I wanted the game to be, the features and why it should be fun. But it took me almost a year and a half to prove that the vision actually worked. And it's still, I mean, being improved, but it's difficult when you design something like that because it doesn't matter if you yourself think the game is going to work. It's different from other research where you can kind of prove it on your own. You have a theory, you prove it, and that's all good and well. In this case, the only way to actually prove that the vision is correct is to have hundreds of people playing it and gathering data from that, and that takes a lot of time. And I learned a lot when it came to actually explaining what my vision was, because I come from a point where I understand the challenge well, I understand the means, and I have a decent understanding of humans and how we work. But that was tough to be able to explain to other people. So the typical feedback I got was that it's just a simple game. How could that be complicated? Or why do you need funding to develop that? Why don't you just write it on blank playing cards and get done with it? I try to explain that there's a much, much higher vision and a tremendous amount of work behind it. But the things that made me the most happy during the process, well, one of the comments actually came from when I visited this fine university in INGENIUM in February, and one of the players actually said that they never really realized how little security they actually know. So one of the targets I had with this game was to get people to have an insight into that. Many of us expect that we know security, but once you scratch the surface, you don't really understand it. And this was a very spontaneous comment after the playing session we had in SAMK, and that really made me happy. That's one of the things I think about that continuously, because that's exactly the kind of experience I want people to experience. Another round is we did a play test at a very famous consultancy firm, actually, an international chain. And they loved it when they did the play test, and they've been bugging us numerous times actually for us to come back during and after work so they can play the game drinking beer with colleagues. So people who have actually played this during our data gathering actually talk to their boss about having us back so they can play it again just for fun. Another aspect is when we've done play tests that we actually have to stop people playing. We have to go in and literally tell them we only scheduled 90 minutes. You have to stop playing now. And that's also a very fun experience to have. I think the first major playtest I did, the fact that I had to stop the players from continuing because they wanted to continue playing made me tremendously happy, because it really showed that the vision worked. In our evaluation, 80% of players prefer this game to any other method of gathering security awareness materials, which is flabbergastingly high. It's surprisingly high, but roughly 80% pick this for any other form of security awareness training, which is massive, because most of our players are really experienced in the field. It's people that's worked for a long time. But we also have the good problem then, and that's what do we do with something like this? It's the next step. The second step has taken a tremendous amount of work and cost quite a lot of money. But developing it further is because people want to use this on a scale that's much larger than I am, and that's a good problem to have. But it's also a new problem. But I am happy that the problem I have is how to do something else with a very successful concept rather than trying to save a non-successful program. So that's some words about what we learned so far. So thank you all for listening. I think I stuck roughly to the timeline. So thank you all, and I'm happy to answer any questions.
Thank you, Marcus, very much. I also had an opportunity to try this live. And usually when we talk about gaming, we think about online gaming.
Yep.
But this is something so different. This is tangible. This is, working together with other live people and learning through communication also.
And it's
So now,
one of the things that's, just to add to that, one of the paradoxical things is that of course, I come from an IT background. My first notion was to create a computer thing, and especially using AI or whatever. But I realize now that it's enormously powerful to get people away from the computer. So we spend so much time trying to learn things quickly through the computer, and I just don't think that works. So it ended up that my notion was to go digital in whatever, but now I realize that I think I shouldn't do that, because I think the analog aspect and the people meeting people is a very powerful thing that's hard to emulate digitally. Like we can see in this case where we have, what is it now? 20 participants, and 2 of us have our webcams on. So it's difficult. I'm not being here, but I'm just showing that the human meetings is very difficult to get done digitally, because we tend to go offline quickly. So for most of the presentation, I was speaking only to myself visually, and this happens digitally. I'm not at all, I mean, this happens all the time, but I do think that if you have people sitting around a table, and you have a cup of coffee or a drink or a beer, like some of the beta testers happened, something completely different happens. And I think we should all be very aware of, we cannot digitally emulate the experience of sitting around with other people talking to them, because you just cannot turn off your webcam.
yes, spot on. Now we have time for a quick question or comment. You can just open your microphone. Well, if there aren't any, you can comment or ask in the chat.
Absolutely.
Also, yes. Thank you so much, Marcus.
Thank you, everyone.
This was so interesting. Okay, next up we have Professor Neumann from Karlsruhe University of Applied Sciences, our German colleague. And the topic is gamification as a driver for motivation.
Yes, okay.
Oh, there you are.
Everybody.
Okay, you have the floor now.
At the floor, okay. The bottom line. No, thanks, Marcus, for the interesting, very, very good idea about the security in games. Since I'm the Chief Information Security Officer at our high school, I know what it means to educate or to sensibilize people on this topic. And yeah, gaming is one key. Okay, let me just share the slide. I hope that should work fine. Does it work?
Yes, it works fine.
Okay. Well then, the topic of my talk was like gamification as a driver for motivation. So what do we need gamification for? Maybe up front, I failed several times in providing gamified lectures. I tried several approaches, like even programming serious games. And as Marcus already said, this is a real large effort, and you don't really know whether the people really react to the game in the way that you want that. So I tried rather to step back a little and said, why are we using games? So what is gamification for? And the basic idea of gamification is you don't have to use a game. You want to use a game. If it's fun, then you do it, and you do it for a longer time. And the consequence is that and this is one of the key parts, is that the motivation and the engagement that you access with a game, like people getting involved into a game, they get pulled into that. That makes up a large engagement. So this is the core idea. As I have learned in several leadership trainings and so on, that people, when playing games, they don't pretend to be someone else. Often they are very authentic, and you get better reactions if you're playing live games. So this is just one thing. Okay, now getting to motivation not to bore you, this is just you distinguish between the intrinsic and the extrinsic and motivations. And of course, intrinsic is typically better because I want to do some things. There is one thing like internalizations, so that you can accept the external motivation. But okay, let's skip this one and go to some of the theories in the background. I'm not sure who of you is already familiar with some of these motivation theories. I don't know. Could you maybe just give an impression who of you already was dealing with some of these? Just nobody. Okay. Maybe I need some minutes to run over this one. One of the very old theories of motivation is the one going back to McClelland, where he says, okay, there is for different aspects like affiliation, power, performance, there are wishes and there are fears, and we need to fulfill those. Motivation says we are motivated because we have our hopes, like we want to be recognized, or we want to get in power of something. And we have fears. The fear of loss of control, for instance, is sometimes a hard thing. While this is a very old theory, I'll skip a little bit to a newer one, which is the so-called self-determination theory, which is based in 2008. And they say, okay, we have three main aspects. And this is where gamification comes in. We'll see this later on. And one thing is you need to be autonomous in a way, like you need to be able to do things. You need to be free to choose what you do. You need to be able to do things, which is the competence sector. And you need to relate to the things that you're doing. And the nice thing is, if you only have two of the three parts, then this doesn't work out in a complete motivation. If you're competent and you're related to the topic, but you cannot decide on your own, then this is just check marking checklists, and this is nothing that gets you engaged. As well as if you don't know what the hell am I doing this for, then you might be autonomous and competent, but yeah, this is you're just doing for whatever reason. Okay. So these are three basic motives that we often see, and you see them in a slightly different way over and over. I don't know who of you already got in touch with this guy here, Daniel Pink. There is a very nice video that you find on YouTube using RSA Motivate, where he describes his book, The Surprising Truth of what motivates us. And he also comes to three motivators, where one is autonomy, which we just saw. One is mastery, which relates to the competence that we just saw, and one is the purpose, which is like we already had the one in the slide before. We had the meaning. Okay. So you find, looking at motivation theories, you find this over and over again, that you need to be able to do something, you need to have the freedom of choice, and you need to have the epic meaning. And this is one part of playing.
I think we lost.
We lost you for a second. Are you okay?
Yes, I think my screen sharing is right now on again. Not
okay. The share is not on, but you are there.
Oh, okay. Don't know what.
Okay, here we go.
I thought the talk was so bad that you just kicked me out. Okay. The purpose is, by the way, the thing that Marcus already mentioned when he talked about the vision. Why are you doing this? What are you doing this for? And I think the vision and the epic meaning is one of the core ideas. Now, this is what motivation says. And there is another thing to games, which is it is fun to play. And there are different types of fun. And Nicola Lazzaro, she developed, she's a coach in this gaming and design era. And she developed her 4 keys to fun, where she distinguishes what kind of fun we have. There are different kinds, like Easy fun is like playing like small arcade games. Serious fun is more the level of games that Marcus just talked about, like this is solving real world problems or simulated problems. The hard fun is getting better at something and accepting challenges, and the people fun is community building. So she distinguishes between four aspects of fun. There's a different visualization of this where you say, okay, if you think about the serious fun, then this is maybe some relaxation or so. I'll skip this one. Okay, so now we have the motivation and the fun thing, and how can we use this in gamification to maybe produce better results, to improve and so on. And this is where another motivation theory that I personally really like to see as how can I improve my working or my teaching environment. And this goes back to B.J. Fogg. I don't know if you know this behavioral model according to Fogg, which is like small steps for self-improvement and so on. And Fogg also comes on with three things that make up his, everybody needs to have three, I think, three aspects of his behavioral model, which is the motivation that we've been talking about. He separately accesses the ability, which is, am I able to do things? And then he says, in order to get better, to improve, I need prompts. And I'll show you this one in a small diagram that Fogg uses. It's a little bit tricky to see this one. On the vertical dimension, he has the motivation. So if you have low motivation and you need to do a job, then that job should be very, very, very easy to do. Because if you're not motivated at all, then this is, and you get a job which is a little complicated, you fail. If you have a job that is hard to do, it requires a high level of motivation. And if the difference between your ability and the difficulty of the job is too high, then you won't succeed. And this action line that he has here is, in order to improve, you need to accept challenges, and then we need to small triggers, like he calls them prompts, triggers, reminders, pop-ups, nudges that push us in the right direction. And we need them at the right time, and we need them in the right amount, so that we catch up everyone in his or her scale of ability to increase the motivation. Not sure if that makes sense to you or if I'm talking wrong. So when it comes to Fogg, he says, okay, we want people to get better at their working environment, to understand things better, and we need to give them small challenges that they can accept. Marcus started with a password cracking thing. Now, if I would have complete newbies in the security sector and say, is this a secure password? Try to crack this password, they would fail immediately because they have no experience in that. By the time they get experienced and they know the techniques, then that might be easy. So I need a little harder challenge on this one. And you need to think in two directions. The one thing is the ability. We often assume that people are able to do the job, or we send them to a training and say, okay, now you're able to do the job. But it often requires a little bit more training than we imagine. And I just had a meeting with some administrative people this morning who were complaining about, hey, I'm not the expert that I should be in this area. I don't have the tools and the cookbooks to maybe deploy some special software. So training is one thing, but tools and cookbooks and communication is another thing. And one very, very hard thing is to get people to make things be or feel easy or simple. I guess this is also what Marcus already said, making things in a way that they are simple or easy to use, or they feel easy. What Fogg calls scale back. The simplicity is really hard to achieve. And in my opinion, those second two parts, tools, cookbooks, and scale back simplicity, are key, at least in working environments, to keep people improve on their skills. This and the tools and cookbooks require some sort of community, where the scale back requires you to rethink processes in a way that you don't think about efficiency first, but effectiveness instead. So you don't want to get faster with a wrong process, but you want to get the better process. And this is often what you need to think about in simplicity. Okay, now at this borderline where your motivation is high enough for the job, but the job is a little bit, you're a little bit over motivated for your skills, then this leads to prompts making you learn and develop skills. This is what you read from this diagram, okay? And so the parts in fog is you have those triggers, reminders, pop-ups, and tips, and so on. And now coming back to this gamification stuff, what does it mean? Triggers, reminders, pop-ups, and tips could be seen as some sort of gaming elements. Okay, this is like don't know what kind of gaming elements you typically think of when I ask students of what are gamification elements. Then they come up with badges and high scores and scoreboards and so on. But if you look at playing games, then this is just something, the small triggers that just lead to you may improve, you may get better on things. And there is a whole bunch of elements that you can use for this. And in order to get back to this gamification, what can we do? In my lectures, I use one framework. I don't know who of you already maybe knows this one. This is the so-called Octalysis gamification framework. And this guy on the left side, Yukai Chao, I think he didn't finish his studies. He just went to be a consultant in gamification because he knew playing games. He's a very highly skilled player, and so he said, "This will be my job." And he came up with a, in my opinion, pretty clear framework on what aspects do we need to get in mind when we think about gamification elements, and what do we want to accomplish with them. And the framework is called Octalysis because he has these 8 dimensions, where the meaning, the epic meaning, what they call it, is on the top. And you have different aspects of what this means for your players. The epic meaning, for instance, if you know what the higher good is that you're doing for. I know we have a job at university, and there is a meaning in the job itself. Okay, and since I'm working on this one, I'm working with the young students to make them find their way. So this is an epic meaning for me. This is very intrinsic motivation. If you look at the very bottom, avoidance, this is maybe why people don't leave X or Facebook or so, because they have a whole bunch of data already in there. Maybe you can think of it at the sunken cost model of gamification. Like you don't delete a game from your PC if you have all these badges and so on. And there is one thing about gamification, the unpredictability. And I would like to give you just a small real-world example of how we can improve real-world processes by gamifying. You know, these traffic lights where you get a ticket when you're speeding ticket when you're too fast. And everybody's angry about those, or many people are angry about those. Now, we want to have people to behave in a good way, but not blame the police for this one. And there was one community, I think it was in the US, that came up with the idea, no, we don't only take the license plates of the people driving incorrect, but also the people driving correct. And all these people get into a lottery, and those who drove correct have the ability to win some of the amount of money that has been spent by the others being too fast. And doing this, it led to people driving correctly because they had the chance of winning. So this lottery thing sometimes turns real world situations into some funny settings. Okay, going back to the Octalysis framework, we have several dimensions in there, and just to like they see it is on the top you have the positive or the white hat motivations, like this is epic meaning and empowerment and everything that's good about it. On the negative side, you have the black hats. You're afraid to lose some experience. Scarcity is the typical thing that if you want to sell things, then you say there's only 2 left in stock. So the people try to you try to nudge in a way that they buy faster. And so this is black hat. This is not the positive one. If you now come to what can I do to improve each of these sectors, then I encourage you to look at this. It's on the website, and you can play around with this one. There is a whole bunch of gaming elements that you can use to increase each of these. And now this is not, as I mentioned with a traffic light or speeding ticket, this is not just focused on technical games, but this is what we have in learning environments also. We have sometimes unpredictability, like giving some weird examples and let people think of something that they didn't imagine right now. We have, of course, something like progress bars. If you represent their own progress to students, you might have some sort of badges, but you need to be careful with badges in this one if it comes to working environment. And we have that right part, which is the social influence, like this is building your networks in there, building teams and so on. There is another thing that we need to consider when we look at games, and this is we are not always in the same phase of the game. So if we use the game that Marcus, for instance, said to how can we educate people in the security way, then there are different phases in these games. When you discover the game, then the curiosity and unpredictability are maybe key. If you go on, maybe if you think of one game over your university studies, then there is some onboarding where you get to know things, there is some scaffolding, and in the end game, you try to avoid people leaving there. So there are different phases, and there's different elements that are more important at the beginning than there are at the end. And now coming back to what we can do in our environments is like if you think of players, then there is a typical distinction between several kinds of players. Some are more on the acting side, some are more on the interacting side, some are more interested in the content, like in open world games, some are more interested in other players. And so you have different kinds of player types, explorers or compete, which are sometimes also called killers, and if you think of some gaming frameworks. So you have different people who play in different sectors. And now gamification means that you need to think of what kind of player are my students, my colleagues, what is my team? Who is what kind of player? Because if you challenge an explorer with a killer game, like you need to defy enemies, that's not the game that this person will want to play. And so we need to think of who are we playing with and what are the motivators for those to play. Okay. And I'll give you just some examples of where you need to be very, very careful, which is basically like, I don't know if you heard this term in companies, like how about a little in-house competition? Yeah, we need some in-house competition to get innovation driven. Or I give you a bonus for innovation. This may completely destroy the team climate or the team, because we need to consider what I wrote on the bottom line. people like playing, but they typically don't like losing. So people play games as long as they have the chance of winning and to stay in the game. And if we try to see some playful elements like challenges in real-world settings, in teams, in lectures, then we need to be very careful, because you will lose some of your players who said, this is not my game, or I don't have even a chance, like this one. And this is also something that we have to be very careful with public rewards, like badges or leaderboards or something. Leaderboards come from the playing area, where people who are highly engaged in the game want to be on top. But we don't look at all the thousands and millions who are not in the leaderboard. And now, if we come to a real-life learning setting, the leaderboard might make you lose those people who are not in the leaderboard or who don't have the chance. For instance, if you have different types of employees, full-time employees and part-time employees, they have different settings of how they can play and how they can engage in certain games. Now, rewarding the full-time employees or full-time equivalents may lead to frustration on the other side, because they are not in that game anymore. Okay, so we need to have that game being the rules being on the fair level. Okay, and maybe some advice might call it. This is maybe some learnings that I had in the last years when I was dealing with gamification in business or in teaching settings, which is in work settings. My opinion is that, at least if we are in an intellectual setting, like we are in this group or in this INGENIUM setting, self-determination is key. If we tend to tell people what exactly they need to do, we will lose. This is about the motivation thing. If we think at the motivation again, meaning, the epic meaning is something. I told you just in the Octell's framework about the right-hand side, where it comes to socializing, social networks, and as I already mentioned, no forced competition. Because if you force competition, or you say, yeah, let's see who comes up with a better concept, that might be okay if the players agree on they want to play and they want to have the challenge. If you push it onto a team who doesn't want to play or who has a different rule set, you will maybe lose those guys. In the education setting, one of the key learnings for me was traditional learning was like giving lectures and having an exercise. But actually, I don't want the people to have a certificate behind. I want them to learn something, which means I need to give them feedback immediately on how they proceed, which is more like a progress indicator and feedback. And when I try to push them a little, then I need to clearly define the prompts. Okay, how can I push you to a way where you're not out of your comfort zone, maybe? How can I put individual challenges? And how can I help you to win? But in this case, please keep in mind, there are different player types, and pushing people who don't want to be pushed because they may be introverted and are afraid of a public setting and so on, you might also lose those. So there is no easy way to define in games. There is no easy way to use that gamification in work settings and education settings. But if you just say, okay, I need badges, I need public rewards, I need challenges, then you're using some game elements without thinking of the consequences, which might be bad. Okay, and I think I took some overtime, so I hope that wasn't too long. So
no, we are fine. Thank you very much. A very interesting framework for our thinking of gaming. Now we have time for some comments or questions. Marcus, please.
I think he was just clapping.
Are you clapping or are you raising your hand?
It was just an applaud here, so I should probably be. I'm the one person who should be quiet, so someone else can have some space here. But thank you for a good presentation.
You're welcome.
Okay, again, you
Well, maybe one last thing. As I already mentioned at the beginning, I failed several times in providing games during lectures. But this is, yeah, you need to play around with these elements, but really be careful. You're dealing with humans, you're dealing with people with personalities, and you need to make sure who wants to play which game.
Mm.
Okay.
Yes, I think I've noticed the
point.
same also with students. If they are very competitive and they notice that they're not winning, they just quit.
Yes. And then you lose them, but you want to educate them and not
Exactly.
to have them. Yeah, okay.
Okay, Marcus, did you want to say something?
No, I think it's a very good point about the competitiveness. I mean, very easy. The game in itself becomes a goal and not the learning, and that's so one of the things I realized. I mentioned in my presentation that I had to design a non-solvable game because I know a lot of my students are exceedingly competitive when it comes to these things. So they would try to crack the mechanics of the game to win points. So it wouldn't matter with the learning. That's why I added cards, so you couldn't optimize you can't win the game by learning the cards by heart. So there's still an added mechanic, because that's the way my students work. Not all of them, but enough of them that they would just create code words and not cheat, but exploit weaknesses in the games. And that's well worth mentioning, because that becomes a game in itself, which is to cheat the game. And that's something that when I started to design that, I assumed that everyone would be playing the game with a good heart. But it turns out that as soon as there's a winning objective, people will optimize for winning. And that's a very difficult thing to happen, because you can create a very bad mood.
By the way, this is something that you do if you have, for instance, have variable salaries, like you have provisions. If you don't carefully design those, then people tend to sell anything without looking further. Like you also see companies just thinking from one quarter to the next one. Then they optimize for that and not for the meaning.
Yep. So
okay.
One of the fun things I learned here is my game isn't fair. There's built-in conflicts, and that takes away a little bit of the element of the students that wants to optimize the games and just exploit the rules against them. So there's a built-in, who knows aspect, and they have to deal with it. But that actually works with social learning. So you have to negotiate the way you want to play the game. So that became a powerful thing, because I realized if I wanted to create such a non-exploitable gaming rule set, it would take a lot of time to get started, and that would take away from the fun.
Yes, one part of the fun is unpredictability. So what you just mentioned is there is some sort of unpredictability where you get surprised and you need to react on this one.
Yep.
And that might be a key point in some parts.
That's a brilliant point.
Okay, thank you.
So
thank you very much. And now we still have one presentation to go. So our Romanian colleague, Cristina Vatavu, will talk about game-like activities in electrical circuits. Sounds very, very exciting. The floor is yours.
Good afternoon, everyone. Do you hear me well, please? It's possible to say?
Yes.
Okay,
oh, yes.
Okay. First, I would like to thank Tina Parkkonen for inviting me to speak about gamification at today's anniversary INGENIUM webinar, right, the 10th. It is a real pleasure to be here and to share some of the methods I use with my students. I hope I can keep the bar as high as the previous speakers, Professor Markus Nohlberg and Professor Rainer Neumann. And I would like to congratulate them for their inspired presentations and their inspired work, of course. I'm a lecturer in the Department of Electrical Engineering at Gheorghe Technical University of Iași, Romania. And when I saw the call for contributions on gamification, I realized that many of the activities I use in class are in fact games. They may not follow game design rules strictly, but they create learning experiences in non-game context, experiences that increase the student engagement, motivation, and participation. And that is what gamification is about, actually, probably. And that is what brought me here today. About the game. Before introducing the game, let me briefly set the context. The course where I used this game is about electrical circuits and the laws that govern how they work. At the beginning, students learn the basic circuit symbols, how to read electrical schematics, and the fundamental ideas behind how a circuit is built, what we call circuit topology. The students are first year freshmen attending some of their very first university classes. Many arrive with little background in electricity or even no background. And so I start from scratch. I use simple stories and analogies. For example, I tell them that electricity is a product being traded on a marketplace that exists only inside the circuit, and energy transactions only happen when electrons move, and so on. How electrons are organized and how energy trading is established. But even with these explanations, I noticed something important. Mental image students build is often not the one I intended. From my perspective, the information seems clear, yet what they understand can be quite different. And to correct this inaccurate mental image, I first needed to see what the image looked like. The game I will present today focuses on circuit topology. This game helped me discover where students' perceptions were distorted and significantly improved their understanding this game using this game. I call this game blind copy. What is blind copy? But if I told you that one of the most effective ways to teach electrical circuit topology is through a game where students are not allowed to see the circuit. Sounds counterintuitive, but that is exactly the purpose. The main purpose is to help students understand the key concepts of topology, nodes, branches, and loops, and to change the way they normally look at electrical diagrams. Instead of seeing them as drawings, they begin to see them as structured networks of interconnected elements. Blind copy develops essential soft skills that future engineers needed. Communication, teamwork, collaboration, and all this emerge naturally through this activity. We use the game after students have been introduced to the basic concept, of course, and how it works. I want to display how it works. One student stands at the board ready to draw. Another student sits behind them, facing away, holding a sheet of paper with a circuit diagram that only they can see. So one can see the circuit but cannot draw it. One can draw the circuit but cannot see it, and neither can see what the other is doing. There are two important roles. And there is the third one. So we have the sender of the information, the receiver, and everyone else is the audience. They are observers of what unfolds. The sender must describe the electrical circuit using only words, no gestures, no pointing, just verbal explanation. The receiver listens and tries to recreate the circuit on the board step by step, and they are encouraged to communicate. The goal is not a perfect drawing. The goal is understanding through communication. We consider the exercise complete only when every student has experienced all three roles: receiver, sender, and observer. The sender communicating the information, the receiver interpreting the information, and observer evaluating the communication process. It is very important also this position. Instead of just imagining it, I would like to show you a few recordings that I do these days in class. So I would like to show you what it looks like in practice. These are the examples, the circuits that I experienced with students, and I recorded. This is the first one. I'd like to know if you can hear.
Okay, so place a voltage generator.
Yes, we can hear.
Go up, go right, up again, right, and place a current generator. Go further, down, left, and place a
Stop. I don't know why. It stopped, right?
resistor.
Okay.
Go further and down, place another resistor. Go right, up, and place a resistor. Go further and go again right and then down and place the last resistor. And then connect everything.
Connect everything. It's type of mistake.
So, okay, let's start. So we have the source. Okay, going out from the source and to the right, we have two transistors in parallel.
Transistors or resistors?
Resistors, sorry, resistors. Okay, now from one of the resistors, we have another resistor in series this time. Okay. Now continuing from the original line, we have another resistor in parallel with the other two resistors that were originally in parallel. So you have two sets of parallel transistors. The first one and then the second one. Okay. So you have four transistors and one source, that's right?
That's right.
Okay, and did you connect the circuit?
As you can see, unuseful information is transmitted. And also the receiver doesn't ask about.
Source we have the 12 milliamperes.
So,
So, in the beginning, you have a battery. Going from the positive
Is it a
side.
generator, which is a current generator or a voltage generator?
Actually, I cannot remember that. It's with you have a circle with a plus and a minus inside.
So voltage generator.
Okay. You have to have around. Just a second.
It counts the elements, or
5
I don't
nodes, I
know.
think.
which is unuseful also.
Yeah. You will have to have 5 nodes.
Is that helpful to count the
Actually,
elements?
no.
No? So don't do it.
Yeah. You have to connect to the battery a resistor that is oriented to. Actually, no. Just connect a resistor. Then from that resistor, you go down, have a node, and go to and connect it to another resistor.
Let her go down. Doesn't have enough room to go down in this one.
They talk a lot in terms of downs and ups and rights, which is not important in electrical circuits.
What else do I draw from that node?
So you have firstly a resistor connected to node.
That's the name is node A.
What?
Node A. That's called it.
Yeah, from node A, you connect the battery to a node A, and you connect the node A to a resistor. Then from the resistor, go to a node B. The node B goes to another resistor. Then from node B, you connect another resistor to. It's in R3. So basically, from a node B, you have 3 resistors.
Too many information
A, one resist and 2 other resistors
that cannot be processed by the receiver.
connected to separate points.
All right.
So now you should have resistor 1 connected to node A and B, resistor 2 connected to node B and going to a node C, and the resistor 3 connected from node B to node D.
Was there a resistor between node A and the voltage generator?
No.
All right.
And so on.
So the voltage generator is connected to
Slowly, but
1A and 1B.
in the end,
Between node A and B
will be found on the good
resistors
way
and node
describing the circuit.
Actually, no, sorry. So from the battery, you'll have
We have in this case a good receiver.
to A and C,
She can
nodes A and C.
put the light
Between
where
nodes A
is
and
necessary.
C, you'll have 2 resistors that are connected through a node.
It's also a failure, so I'm going to the next example.
All right. We will start with a current generator with the arrow pointing up. You will call that
with the
arrow pointing up.
Yes.
And you will name it IG. From there, you need to go up and a little bit to the right.
With the right.
Yeah.
Yes.
Then you will go down and put a resistor R1. Then you will go down and right, and you will have a voltage generator. And the plus will
So,
be...
so wait, at first we have a current generator.
Yes, we do have a current generator.
Current generator.
And this one is a voltage generator. And the plus should be where you drew the line, kind of like.
Can you speak a little bit louder? I can't hear you properly.
The plus should be where you ended the line.
All right.
Now you're going to go a little more to the right. Down, you will have a resistor R3.
Sometimes these kind of descriptions are successful, but sometimes, only sometimes.
You have two generators and two resistors at this point.
All right.
Everything, right? Yes, R3. Now you're going to go right and a little up.
Right and then up, right?
Where you will have a third generator. This will be a voltage generator, E2. And called E2, yeah, and so the first one should be called E1.
And the first one
should be called E1. Yeah.
And it is not a successful one either. This
To R2.
you can see the end. Now I want to show you a successful description, which is short, very short, and very clear.
There are 3 nodes. Okay. You can know them A, B, and C. Between node A and right, my fault. Okay. Between node A and node B, okay, you are going to have a resistance R4. Okay. And on another branch, it will be R2 and from A to B. Yes. Okay. There will be a resistance R2 and a voltage generator. From node A to B. Yes. Although the voltage generator is from B to A.
The plus is
the plus is towards A.
Is towards A.
Okay.
Towards A.
From node A to node C, you are going to between node A and node C, you are going to have 2 resistances, R5 and R3, on the same path. Okay. R 5 and 3. Okay. From node B to node C, you are going to have a resistance R1, and on another path, you will have a current generator towards node B. Okay. And that should be all.
Very short.
While
You should check also in blind. No.
Oh.
That in the notes. Notes.
Oh, okay.
A is between.
So node A
Is between.
is between R2, the voltage generator, R4 and R5, R3. No.
It's only R2 there.
Oh, yeah. R2, R4 and R5.
All right, I agree with that.
KB is R1, the current generator and the voltage generator.
And
R4?
yes.
Yeah, and R4, I didn't see that.
All right.
It's too close to the whiteboard.
Yeah, sorry.
And doesn't
C
see clearly.
is R3, R1 and the current generator.
That is correct.
And then, well done.
We did it.
Nice job.
I think it worked well. This kind of game, I call it game, when students describe a circuit only with words, no drawings, no symbols, they suddenly discover how difficult it is to communicate something that, for us as engineers, feels obvious. I used this game with students and saw huge improvements in their perception. That's why some time ago in 2018, I did a study to evaluate the impact of this game on students' learning. I worked with 100 first-year students, divided in 4 groups of 25. The only difference between the groups was when they played the game during the learning process, the time. And to measure the impact, And to evaluate the results of applying this game, students completed the same challenge before and after the game. The challenge was to describe an electrical circuit in writing using only words. I defined 6 performance indicators: identifying the nodes, identifying the branches, identifying the loops, labeling the elements. So the explanation made sense. Correctly naming the components in each branch. These are analysis indicators. Analysis indicators, I1, I2, I3, I4, and I6. So I5, the correct identification of the elements. And the 6th, explaining the connections clearly and concisely, very correct. Not all indicators have equal weights. If students identify nodes and explain how everything is connected, which these indicators are 1 and 6, they already have a solid description. But aiding labels, which is indicator 4, greatly increase clarity. The others indicators, the others add value, but are not essential for understanding topology, like loops are not essential. The results of the study were evaluated both quantitatively and qualitatively. The quantitative analysis examined the written descriptions before and after the game, and we looked at group level performance before and after for indicator and overall to the group evolution, how much each group of 25 students improved, and of course at individual evolution, how each student progress. There are 4 figures that show the group results graphically expressed as percentages. Also, there is a figure where you can see a direct comparison of how much each group improved, essentially their knowledge gain score. Also a table where is summarized the quantitative performance for all 4 groups. And the second one ranks the groups based on their results. Now, allow me to share with you some of my observations. The ranking of the 4 groups, you can see, remain the same before and after the exercise. And that showed to me that the evaluation was fair and did not advantage or disadvantage any group. That's my key finding. Also, the group that played the game at 10 a.m. show the greatest improvement. Okay, 10 a.m. 41 points. Across all 4 groups, the largest improvement occurred for indicator I4, the labeling, which is exactly what the game trains. Strong confirmation that the game works. Also, we have another interesting thing, the group from 8 a.m., which is considered sleepy or less engaged, actually performed best on indicator 5. Is you can see indicator 5 is the best for 8 a.m. There. And is another interesting thing is one result that is the same for all groups. I3 decreased after the exercise for all groups. And that may look like a negative outcome, but actually it can reflect a positive shift because students learn that the number of loops is not essential. This I3 is about I3. The number of loops is not essential for completing the task correctly. In other words, they focused on what truly mattered for communication. They stop wasting time on details, as you can see in previous recordings, and they learn to prioritize clarity over irrelevant information. So the real story behind the numbers is that students didn't just learn circuit topology, they learned how to communicate it effectively. There also is a qualitative analysis here. Qualitative side of the analysis helped us in understand how the experience of the game shaped student learning, not just how much they improved. Before the game, students' explanation showed some knowledge, but it was unstructured. It was scattered. Concepts were mixed and often confused. And describing how a circuit is connected is a storytelling task. And storytelling works best when characters have names. Once students started labeling elements, clarity improved significantly. This is why indicators 4 and 6 were rarely achieved before the game and better after. After the exercise, written descriptions became clear, shorter, better explained, better structured, even when not perfect. And in the conclusion, because students experience all three perspectives, the receiver, transmitter, the observer, the game stimulates a wide range of skills. And what I find particularly valuable is that it develops not only technical abilities, but also human and communication skills, which are often harder to reach and to teach, of course. There are a list of professional competencies, soft skills achieved and built by this game, by experiencing this game, and a list of, professional competences are technical competences, and a list of transversal skills, soft skills. The ability to communicate, the teamwork, the confidence, the constructive feedback, and so on. I can say for sure the game trains both the mind and the mindset, in my opinion, and that combination prepares students for engineering practice. Before I end, I want to leave you with one thought. As my previous speaker, Professor Markus Nohlberg, said that it takes a lot of time to create something simple. This game is simple, or seems simple, but students learn best when they are involved, when they interact, when they feel safe to experiment, even to make mistakes. If blind copy this game sparked an idea, a curiosity, or even a small what if, then the goal was achieved. Thank you very much for having me today. It was a pleasure to share this with you.
Thank you
I would be
very
happy to
much
take your questions.
For your presentation, and thank you for the idea, because one of my jobs is to teach communication to engineering students. So I'm surely adopting your method. Thank you so much for it.
I'm so happy to hear
All right.
that from you.
We still have a few minutes for comments and questions, please.
Maybe one question.
Yes.
I'm teaching some sort of process design, so that's also about the communication issue. Would you consider it useful to have higher semester students who are familiar with the terminology to demonstrate the use in addition to letting the people play around with not yet knowing the perfect language?
Yeah, why not? So you are asked if I consider to let higher level students to play the game in the context of knowing or not knowing.
Yes, in the context of if you have experienced communication on that electronical circuit way, then they describe then they describe the circuits in a different way. So they use the thing with parallel and sequential, and you have three so you have a different terminology. And would it be useful to demonstrate to the undergraduate or to the beginner students how fast that can be in order to get them seeing what are you learning this language for?
Well, I don't work with higher students, but I think it could be useful because, you know, I see things in my perspective, and I am trying to project this perspective to the students. But my perspective shouldn't be the one, shouldn't be unique, shouldn't be the perfect one. So yes, I think it's useful.
Thanks.
Okay, thank you very much. And now before you go, let me just show you the dates for our next webinars. So the next one on the 2nd of December. And if you are interested in sharing something, or you know a colleague who would like to share, please contact us at that INGENIUM email address.